Okay, so, hi. This isn't part of the series. I'm just configuring everything for the video. Can we just admire this sort of menu style for a second? This is really cool. Okay. All right, so what I'm doing here is basically some basic research, which is we play the game, observe the systems, try to pick apart the components. This is the first part of the series. We're going to look at making a third-person camera. I'm not going to get everything down straight away, but we're going to sort of get the basics. Okay, so first thing, I'll use WASD to move around. The camera is somewhere and it's aiming at our character. And see, I go forwards, it pulls forwards. I go back, and the camera sort of pulls back. So the camera sort of moves at the same time as the player, if that makes sense. So it's like the camera is fixed to the player with a sort of boom arm and sort of moves very rigidly. And that's good because when you get into combat, you don't want the camera to be floating around. You want the camera to be moving the same way the player is moving. So that's the WASD movement. We'll look at that. Now, how about the mouse? So here, I'll move the mouse to the left, and it's like, so again, I move it to the left, the camera spins to the right, always orienting towards the player. So it's almost like when I move to the right, it's like I'm moving the player to the right and moving around them. So when I move when I move the mouse up, the camera goes down. When I move the mouse down, the camera goes up. And there are some constraints here. We won't worry about that just yet. So what happens if we strafe and move the camera at the same time? See, the camera has a forwards vector, and when we move to the right, we move along the right vector, but then as the camera spins, the right vector changes. So the character is always moving to the left or right vector of the camera. And again, if I am looking forwards, then I spin around. Now the player moves with the forwards vector of the camera. Does that make sense? So wherever the camera is facing, that is the forwards vector that the player will move along. So we're going to have to get the WASD working together with the mouse movement. That's the second bit. And the last bit is shooting. So if I right click, I've got my weapon and I can shoot. If I left click, I sort of disarm the weapon and go back. So what's happening here? Well, it's like if you picture the boom arm. When we zoom in, the boom arm shortens, so the camera shortens its distance to the player. When we left click, we sort of lengthen that separation. What we can do is we can still move around, but the camera is tighter to the player. So anyway, in this first video in the series, we're going to go through those sort of three features: the WASD movement, the mouse movement, and sort of the zooming in, zooming out. Anyway, let's get into the code. Alrighty, so having done that basic investigation, let's tackle this bit by bit. Link in the description as always. I would strongly recommend you to jump around through this starting code and be comfortable with it. If we run this, we just go to project, just hit run, and we can see this blue thing. It's hard to see at the moment. It's the ground, and this gray box is the player. So I can use WASD to move the player around. And the first thing I want to do is just set the camera up so that it moves with the player. At the moment, the camera is stationary, the player is moving. Okay. So what I'll do is I'll go to the model section. This will have the objects of the game. In this case, that's the player, the camera, the ground, and the scene. And again, I would strongly recommend you to sort of jump in and have a look at this. Let's have a look. Where are we moving the player? Okay, here we're moving the player down here in this move player function. So what I want to do is I want to move the player, but then I want to sort of get back the movement which the player performed so that I can then apply that movement to the camera. So I want this player function, this move function, to return something. So I'll go up here, and here's what I've got at the moment. I'm taking this direction and I'm taking that as sort of an offset around the player's local direction. So that's how I'm getting the WASD moving left, right, and all of that. But let's rejig this a little bit. So we've got the walk direction. I'm pretty happy with that. Let's say make the movement as a vector. And the first thing here I'm going to need are the components of the vector. So I'm going to have the cosine for the x component, the sine for the y component, and we're just going to be moving along the ground. So we'll have 0 as our z component. And we'll make that up. Why can I not type ever? Can we be honest? Why can I never type? Okay, so we'll make that a 32-bit floating point component. Okay, great. So what I'll do is I will just increment the position by the movement. I won't do it component-wise because I've already set this up. The code is now vectorized. Okay, so we increment our position according to that movement amount, which should be working the same as before. Then we'll use that new position to set up the model transform so the player can be drawn. And then finally, whoops, we're going to return that movement vector because then we want to move the camera according to that. So for this, we're also going to need a function for the camera. We'll just call this, I guess, change in position is velocity. And that should be fine. So, and we'll bring this all together. We'll say, okay, calculate the movement and return that, and then move our camera by that same amount. So let's go ahead and give this a shot. We'll open it up and run it. And something seems a little off. Oh, yes, okay. Okay, let me rephrase that. Because we're moving the camera, but we're not sort of calculating it properly. Because we are sort of, if we take the negative of our position, then it's like we're always sort of looking at the origin for our forwards vector. So what I also want to do is I also want to take in a target position, and then the forwards vector will be the target position minus our position. And then when we update the camera, we want to pass in the player's position as the target position. So where are we? Camera update, target position, it's player position. Okay, now see how this looks. Okay. We're looking at the player, and now see, because we are looking at the player's center of mass, which is about the hip level, we're now looking up a little bit. We can see some of the sky. So as we move, nothing happens. And that's actually fine, because the way this is programmed at the moment, the sky is moving along with the player, and that makes sense because it's so far in the background, we don't want it to move at all. Problem is we don't have any scenery in our scene, so it doesn't look like it's doing anything. So we can go to the renderer and go down to the render function. There we are. And right down here, we are setting the position to be the player's position and then move down by a little bit. So about 90 centimeters up is the hip level. So that's why we're moving down. Now let's just change this, comment it out for now. And I'm just going to pass in that array. Okay, and that's it. So now the sky is fixed, and that should give us a frame of reference. So, whoops, wrong one. Now when we run this, we can see, yep, the sky looks like it's moving because the player itself is moving, and it's a little slow. We can probably speed it up a little bit. So we can go over to the app, the control, and when we handle keys, this is where we're calculating the movement. Let's make this about 4 times faster. That's looking better. So we've got WASD working, and the camera is being shifted along with the player. Okay. Great. So the next step is we want the camera to move around when we move the mouse. So we're going to need a different sort of move function for the camera. And I'm going to call this strafing. So in a game, you know, strafing is sort of moving sideways. And that's what the camera is going to do. The camera is going to shift its position according to either its right vector, that's for moving the mouse left or right, or according to its up vector, that's for moving the camera up or down. So I'll make this function, and we're going to shift the position by some amount in the right vector and some amount in the up vector. It's going to take the right amount times our right vector and the up amount times our up vector. This shifts the camera's position. It does not shift what the camera is looking at. So just, by the way, we can sort of simplify this code a little bit. We can set the target for the self-look-at function to just the argument which has been passed in. Okay. Right, so now the question is, how do we get the mouse working here? Well, let's collapse this for now because this function is good. This is done by the scene. So we're going to have an app and the app will take input, so keys and mouse, and will pass messages to the scene which manages its underlying objects. So we can just make a function. What am I going to call this function? Be very imaginative and call it pretty much what it is, strafe camera. Okay, so we just do it. Now let's run this. So we'll go to the control, and then in the control section, we'll make a function called handle mouse. Okay, first thing we'll do is get the mouse position. Then we want to make this frame rate independent. So I'll make a multiplier called rate. And the way I'll do this is I'll take frame time and I'll say what proportion is it compared to the standard frame time. 60 frames per second would be 16.6 milliseconds per frame, I mean. So if we're rendering quicker, frame time will be lower, and this amount will be less. And this keeps the movement sort of frame rate independent. Okay, then I'm going to calculate the right amount and the up amount. So the right amount is basically taking the, if we go screen width, a half of that. This is the X position for the center of the screen, and we want to find our mouse's deviance away from the screen center. So we'll subtract the X coordinate of the mouse, and I'm just going to throw a few multipliers in here. I'll go negative 0.1. Okay, so multiplying by 0.1 will just reduce the sensitivity if it's moving too quickly. Rate would keep it frame rate independent, and this negative is because when I move my mouse to the right, I want the camera to move to the left, and this is just found experimentally. Now let's do pretty much exactly the same thing for up amount. Okay, so we found the amounts we should move along our right and up vector. Now what we can do is send a message to our scene manager and tell it, hey, I want you to strafe the camera by the right amount and up amount. Then finally, I want to set the mouse back to the center of the screen. And the reason I'm doing these double slashes is because to set the mouse position, we need to put in integer amounts. So just in case we have a funky screen height or screen width, this will round it to an integer. Okay, so we've got that set up. All we need to do is go up above to the main loop. And here we're handling a bunch of events. For instance, if we hit escape, it ends the program. We want to handle keys and handle the mouse. Okay, let's give this a shot. So we'll run this. Fingers crossed. Haha, what's going on here? Strange. That's not good. Uh-oh. Makes sense. All right. Okay, so here we see the player. Move the mouse to the left, and the camera moves to the right. Move the mouse to the right, and the camera moves to the left. Move the mouse down, the camera moves up. Move the mouse up. Sorry. It is working properly. I'm just not processing this. Okay, so move the camera down, and the mouse down, the camera appears to move up. Move the mouse up, and the camera appears to move down. Excellent. So we've got that WASD. Now there's just one last thing we need to do for this section. See, when I move forwards, the player sort of moves according to their forwards vector. Even if I spin the camera around, then I hit forwards, it goes according to the player's direction, not the camera's direction. So the last thing I need to do is, after I move the camera, I want to calculate the direction from the camera to the player and then pass that to the player as their new forwards direction. So I go to this strafe camera. This is where I want to perform this. And then I say, okay, well, let's get the direction vector from the camera to the player. And we can do that. Remember, with the direction vector, it's the end position minus the start position. So we want to get the player position minus the camera position. Okay, now I want to calculate the new direction. So I want to go, this is called arctan. Now there's two functions, arctan and arctan2. Arctan2 will calculate tan in the correct quadrant. So the way this works is we pass in the y component and the x component, and this gives us the angle in the correct quadrant. So I want to go camera to player Y component of that. I'm going to pass in because I want to get the horizontal XY axis angle. And then I'll pass in the, oops, not that one, the X component. Okay, now we're going to have a problem because in our system we're expecting angles to be in degrees. This numpy arctan2 will return radians. So what we can do is simply convert it to degrees with this function. Now that we've got that, we can go self player theta is the variable for the horizontal angle. Set that, pass in the new direction. Okay, fingers crossed. So let's give this a go. Okay, so we want to aim this way, and we're moving forwards. Now we spin the camera, and now we are moving in the camera's direction, not the player's direction. So this means that we'll be able to, I'm going to have to change that in a second, but that gives me, that's okay for now. So this means that we can sort of circle strafe like we were doing before. And let's just jump in and fix this graphical error. So what's happening is this little corner of the skybox is going beyond the camera's range, essentially. We can fix that by going to the view and set one-time shader data, and we'll set the far range for the projection, make it a little bit bigger. Now, ultimately, this isn't going to be an issue because at the moment, the sky is fixed in place, which is not realistic. In the final version, the sky will be moving with the player, and so we won't have to readjust this distance. But for now, that should help a little bit. Okay, so we've got that. And now the final bit here is getting the camera zooming. So remember, when I right-clicked, we went into shooting mode and we zoomed in. And then when I left-click, we went out of shooting mode and sort of pulled back. So what I'm going to do right now is we can go to Control, and I just want to investigate events. So I'll go if event type is mouse button down. I just want to investigate the difference between a left click and a right click. Now it all comes down to event.button. So let's just print that. Let's go print event button and see what happens here. Okay, so here we've got the system from before. I'm going to left click and it's telling me that's button 1. I'm going to right click, it's telling me that's button 3. That's interesting. Now if I play with the mouse wheel, press the mouse wheel down, that's button 2. Mouse wheel up, that's button 4. Mouse wheel down is button 5. So hopefully this gives you some ideas for event handling, event detection. But at the moment, I just want to look at left and right click. That's button 1 and 3. So we can go back here and we can say, where are we? Control. We'll say if event button is equal to 1, then that's a left click. Otherwise, if event button is 3, that's a right click. So then the question is, what do we do? Remember, we have the control class, the app. The app takes input and it sends messages to the scene manager. And the message we want to send the scene manager is either pull in the camera or shoot it away. So let's go back down here. And I'm going to make a function for both of them. I'm going to say set zoom. I think it's set camera zoom is what I had before. Okay, so remember I was saying we want to visualize the camera like it is attached by a boom arm. So I'm going to make a variable called arm length. So I have camera arm length, and I'm going to set that to the zoom level. Okay, now let's go take our scene, set the camera zoom. Now if we left click, we want to zoom out. I'm going to call that a zoom level of 7, so a distance of 7 meters from the camera, if you will. And if I zoom in, I want to go a distance of 3.5 meters from the camera. So I want to pull in a little bit closer. Now, how do we handle this? Well, we go to the camera object, and in the camera object, I'm going to set this property. I'm going to say arm length. By default, we're going to be zoomed out, so we'll set that to 7 meters. And then when we update, I want to test, are we too close or too far? So I'm going to make a variable. I'm going to call that, it's a direction vector, self to target. And again, that's the end position minus the start position. Okay. And then I want to get the distance of that. So distance, we'll just go use Pyre's length function. And we can now actually, if we look here, this is the same variable, so we can actually pass that in there. Okay, so what do we want to do? Well, if we're too close or too far, then the absolute difference of our distance, so remember the distance is the length that we actually are from the target, and then think of arm length as like the sort of length we want to have. So we'll say if the absolute of, it doesn't matter because absolute value, same way, distance minus arm length. If that is beyond some threshold, which I'll put at 0.1, then we want to move the camera. Now, let's think about it. If we are too far back, so distance is larger than arm length, then I want it to move forwards along the forwards vector. But on the other hand, if we're too far forwards, so distance is less than arm length, then I want to move backwards along the forwards vector. So make forward amount, and I'm going to set that to, we'll go distance minus arm length. So this will be a positive number if distance is larger than arm length. And in a positive number, we'll be moving forwards. And then you can see in a negative case, we'll be moving the reverse of that. Now there's one more thing that I want to add in, and that is my delta time rate. I have to update all of this in a second, but I'll just code it in for now. Okay, so then I'm going to make a function called move forwards. Function called move forwards. And we'll pass in the forward amount. And this will actually be pretty similar to strafe. So if I go down to strafe, I can make a copy of that. And we'll just take forward amount times the forward vector. And that's it. There we go. So, yeah. All right. So, where was I? All right. That's looking good. Okay. So, camera update. I'm going to pass in our DT multiplier, but then, of course, we're going to need to take a DT multiplier. So, I'll go back to my app. Now, my app will send a message to the scene to update, and we'll take just the same as before, our frame time as a proportion over 16.6 milliseconds, pass that in, and then fingers crossed that should be working. So let's give that a shot. Okay, so if I right click, I zoom in, I can bang, 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 I can shoot. If I left click, I zoom out. Now, it's not perfect, is it? Because we're almost sitting directly behind the player, which means that we're sort of blocking the player's blocking our line of sight. But we'll have to sort of investigate this. So one option is we could add an offset along the camera's right vector to position it slightly off center. And then the other option is this is just the collider box, which will be used for collision testing. So ultimately, the actual model that we use might be less visually obstructive. But anyway, I'm rambling. So that is it. That's our first bit of gameplay programming. We have key movement. We have it working with the mouse. And we can also zoom in and zoom out. And hopefully this code is nice and clean and it's easy enough to extend. Anyway, hope you enjoyed that, and I'll see you again soon. Bye.